Your textbook calls Part C the column method. Actually, the column method is only one way that you can multiply polynomials when one or more of them is bigger than a binomial. When both of the polynomials you want to multiply are binomials, you can use the FOIL method. The first terms, the outside two terms, the inside two terms, and the last two terms. Because the second polynomial here is more than a binomial, we've missed this term completely. We haven't multiplied any of the terms in the first polynomial by this term. So we can't use FOIL, first, outside, inside, last. That only works with a binomial times another binomial. So we need another method. Essentially, we want to make sure that we multiply each of the terms in this polynomial by each of the terms in this polynomial. The approach that makes the most sense to me is to take each term in the first polynomial and distribute it across the second polynomial, one term at a time, to make sure you haven't missed any. Here I'm going to get 2x times 3x squared minus 2x times 2x plus 2x times 1. That takes care of this first term. But what about the second one? To multiply the second term by the second polynomial, and then continue as before, multiply this term by each of the terms in the other polynomial. Negative 3 times 3x squared minus negative 3 times 2x plus negative 3 times 1. Now that I've done that, I can go back and clean things up. 2 times 3 is 6. X times x squared is x cubed. Minus 2 times 2 is 4. X times x is x squared. Plus 2x times 1 is 2x. Plus negative 3 times 3 is negative 9 times x squared. Minus negative 3 times 2 is negative 6 times x plus negative 3 times 1 is negative 3. That's one pass. Let's make another pass and see if we can clean it up even more. 6x cubed is pretty much as simple as I can make that one term. Minus 4x squared plus 2x minus 9x squared minus negative 6x is the same as plus 6x. And plus negative 3 is the same as minus 3. Now that I've cleaned up each term as much as I can, let's go back and combine like terms. This is the only x cubed term. Minus 4x squareds minus 9 more x squareds is minus 13x squareds. Plus 2x plus 6x is plus 8x minus 3. 2x minus 3 times 3x squared minus 2x plus 1 is 6x cubed minus 13x squared plus 8x minus 3. You'll get a lot faster at doing this. But as you do, please be careful that you don't forget things like multiplying by a negative. And you don't use FOIL when it's not appropriate. If you'd used FOIL here, we would have missed the opportunity to multiply anything by this negative 2x. Let's take a look at doing this same problem by the method that your textbook calls the column method. I'll start by rewriting this problem with the longer polynomial on top in the same way as I would do if I were multiplying two numbers together. I'd put the longer number on top and the shorter number underneath. This is a multiplication problem. Using the multiplication algorithm, the same way as I do for numbers, I'm going to multiply negative 3 times 1, then negative 3 times negative 2x, then negative 3 times 3x squared is negative 9x squared. I'll put a placeholder here the way I would do if I were multiplying numbers. This is optional, but whether you put something here or not, remember that the next thing you want to write down is going to go in this position here. Having finished multiplying by negative 3, I'm now going to multiply by 2x. 2x times 1 is 2x. 2x times negative 2x is negative 4x squared. 2x times 3x squared is 6x cubed. Adding these columns together, I end up with the same answer as I did using the other method. Notice that when I add these columns together, my like terms are automatically vertically aligned. That may not always be the case, especially if you're missing a term with a particular power. So, for example, if you multiplied 3x cubed minus 2x plus 1, there's no squared term in here. There's no x squared anything. Because that term is missing, the terms in your intermediate answer may not line up. Ultimately, I want you to notice that my answers are the same. Whether I choose to multiply these two polynomials using the column method or by using distribution, you end up with the same answer. As long as you get the right answer, use the method that works best for you.